Okay, I think pretty much everyone knows this feeling, right? You take that favorite shirt maybe, or I don't know, those perfect jeans
Yeah.
out of the dryer, and suddenly, whoosh, they
Mhm.
fit like they belong to someone else entirely. That shrunken sweater trauma, it's real.
Oh, it's definitely real. But what feels like, just a laundry disaster for us is actually a huge technical challenge for the apparel industry. It's all about managing dimensional change.
Dimensional change.
Yeah.
Sounds technical.
It is a bit. Formally, we call it shrinkage. And that's the reduction in size, the dimensions of a material. And this is key. It applies to both the fabric and the sewing thread.
Both. Okay, I didn't realize the thread was part of the equation,
Oh,
too.
yeah. After things like washing, drying, or even some of the finishing processes they use in manufacturing.
So it's not just like an oops moment. It's something inherent happening in the fabric itself.
Mm.
And the sources we looked at mentioned three main culprits: relaxing tension, fiber compression, and releasing residual stress. That last one sounds kind of dramatic.
It does, but it's a good way to think about it. Imagine stretching a rubber band really tight and holding it.
Right.
When fabric's made, woven, knitted, whatever, it's often pulled or really taut under a lot of pressure just to get the speed and width they need on the machines.
Right. Efficiency?
Exactly.
Yeah.
But all that pulling, that stretching, it basically stores energy in the fibers, latent energy. Then you add heat and water, especially that first wash.
And pop goes the rubber band.
Kind of. The fibers relax. They try to spring back to how they were before, their unstressed state, and releasing that pent-up tension. That's usually the biggest reason for that really noticeable first wash shrinkage.
Got it. So our mission today is really digging into why this happens, these factors influencing the change, but maybe more importantly, how this shrinkage messes with the actual, lifespan of the clothes, the structure.
Precisely. Because, the difference between something that lasts and something that falls apart after 3 washes, it often comes down to predicting and controlling this movement.
It's measured too, right?
Oh.
Like a percentage.
Yeah, exactly. If a label or a spec sheet says, say, 4% shrinkage, that means it's expected to get 4% smaller after a standard wash. But what really jumped out at us from the research, it's kind of failure. It hardly ever happens just randomly in the middle of the fabric.
Okay, interesting. So let's unpack that. Where does the real damage actually occur? Our sources for this deep dive, they point right at the seams.
That's where the action is. It's fascinating because shrinkage, fundamentally, it's a structural problem. Think about it. A big panel of fabric shrinks, but it's stitched to another panel along a fixed line. That shrinking fabric pulls hard on those stitches.
Creating tension.
Massive tension, yeah, and stress. And it concentrates right there at the seam points.
Okay, that makes total sense. The seam line basically takes all the abuse from the fabric pulling inwards.
Yeah.
It's the weak spot.
That's it, exactly. And that tension, it doesn't just weaken the threads themselves, it also damages the fabric right next to the stitches. But here's where it gets really critical for, how long your clothes last. The problem gets way, way worse if the fabric and the sewing threads shrink at different rates. Mismatched shrinkage.
Ooh, okay. Let's dive into that. So, say I've got a basic cotton t-shirt. Cotton shrinks, right? Maybe 5%.
Easily.
But it's sewn with, I don't know, some modern polyester thread that barely shrinks at all, like less than 1%. What's happening there in a tiny scale?
You've basically set up a fight, a structural conflict. The cotton fabric is trying its best to get 5% shorter.
Right.
But that thread, the one that doesn't shrink, it's acting like a tiny rigid barrier, a little steel cable almost. It stops the fabric from relaxing that full 5% right along the seam.
So the fabric bunches up, or?
Or worse, sometimes the thread literally cuts into the fabric loops because the tension is so high.
Oh.
Or the fabric buckles and puckers all along the seam. That mismatch just makes the whole seam way more likely to look distorted. That's called seam puckering. Or even just break completely.
And that buckling and pulling, that's what leads to the obvious problems we see, like seams coming undone or tearing.
It does, yeah. When the fabric shrinks and distorts the seam, the whole shape of the garment changes from how it was designed.
Fit goes out the window.
Fit goes out the window, and the stress isn't spread evenly anymore. It concentrates in weird spots, making it prone to tearing or unraveling. Plus, the shrinking fabric pulls the thread tighter.
More stress again.
More localized stress, yeah. On the thread, on the fabric fibers nearby, everything gets weaker over time. So getting that balance right, matching the fabric shrinkage to the thread shrinkage as closely as possible, that's absolutely crucial.
Okay, so preventing this destruction, this internal battle.
Yeah.
It has to happen way before it gets to us.
Yeah.
This is where it gets really interesting, I think. How do the professionals actually stop this? What are those key decisions during production?
Well, the biggest one, the most critical step really, is pre-treatment, or you might hear it called pre-shrinking.
Pre-shrinking. Get it.
The manufacturers will often wash or steam or use certain chemical processes on the fabric and the sewing threads before they even start assembling the garment.
Ah, so they trigger that relaxation, that stress release themselves.
Yeah.
In a controlled way.
Exactly. They force the material to do most of its shrinking up front. It stabilizes it. So when you, the consumer, wash it later,
There's less shrinking left to do. It's like getting the stress out early.
precisely, it stabilizes the material. Now, there isn't like a single hard and fast rule for everything. A wool suit is different from a cotton tee, obviously.
Sure.
But a common guideline in the industry is if the expected shrinkage is over 3%, pre-treatment is pretty much a must.
3%. That specific number is interesting. Why 3?
Well, it's kind of the point where shrinkage often becomes noticeable enough to be a problem, either visually, like puckering, or structurally, really weakening those seams. Below that, maybe you can manage it in other ways.
Is that 3% purely about things lasting, or does cost play into it? Like maybe pre-shrinking adds too much cost below that point.
It's definitely both. For durability, less shrinkage is better. But yeah, pre-treatment adds cost and time. So it's also about the end use. If you're making, say, technical gear where fit is critical.
Like climbing gear or something.
Right. Your tolerance might be way lower, maybe even 1.5%. But for everyday clothes, 3% is often that industry sweet spot. Stable enough to last, predictable enough to size correctly, without making it unaffordable.
Makes sense. So beyond treating the materials, you also mentioned the sewing itself. The stitch type matters too.
Oh, massively. It's not just what you sew with, but how you sew it. The stitch has to be able to handle potential changes in the fabric dimension.
How so?
Well, think about a really stable fabric, something like a tightly woven polyester or maybe a heavy denim that won't shrink much.
Okay.
For those, you want a stable stitch, something strong that holds everything firmly. That's where you'd use a lock stitch, maybe reinforce it. They're rigid, they resist unraveling, they prioritize holding power.
But if you use that rigid lock stitch on something stretchy or prone to shrinking a lot, like a jersey knit?
Exactly. That rigid stitch would likely cause puckering because the fabric wants to move, or worse, the thread might even snap under the strain.
So what's the alternative for those fabrics?
That's when engineers choose flexible stitches. Things like a zigzag stitch or specific stretch stitches. A zigzag, it looks like a little spring running along the seam.
Yeah, I can picture that.
Because the thread isn't laid down in a straight, tight line, it has inherent give. It allows the seam to stretch and contract along with the fabric as it shrinks or moves. It accommodates the change without putting that damaging stress on everything.
Wow, okay. Rigid stitch for stable fabric, flexible stitch for fabric that moves. That really shows how they engineer the seam to work with the fabric's expected behavior.
Absolutely. And then, once the garment's actually made, there's one final preventative step, and this one involves the consumer,
Okay.
providing really clear, accurate care instructions. That care label isn't just filler. It's basically handing you the instructions to maintain the stability they engineered into the garment. It empowers you, the owner, to keep it durable.
Right. Follow the instructions. Okay, let's shift gears a bit. This prediction, this 3% or whatever, how do they actually know? It can't just be guesswork. There must be testing, rigorous testing.
Oh, absolutely. Quality control, QC, is huge here. This is how manufacturers move from estimates to actual hard data, predicting exactly how a fabric will behave. And it relies on standardized testing methods.
Standardized, meaning everyone does it the same way.
Exactly. Consistency is everything. We mainly rely on global standards like ISO 50277 and ASTM D1930. These aren't just random codes, they're internationally agreed upon procedures for measuring dimensional change after washing or dry cleaning.
Why is having a standard so vital? Couldn't a company just, wash a sample in their break room machine?
They could, sure, but the results wouldn't mean anything to anyone else. Standards dictate everything. The exact water temperature, the type and concentration of detergent, the wash cycle time, how it's dried, everything.
Ah, so it's repeatable.
Perfectly repeatable. It means if a lab in Germany and a lab in Vietnam test the same fabric using ISO 50077, they should get the same shrinkage percentage within a tiny margin of error. That allows for global trade and reliable quality comparisons.
Okay, got it. So walk us through this testing procedure. It sounds pretty meticulous.
It really is. It's designed to eliminate as many variables as possible. First, they cut precise fabric samples. Critically, they cut them in both the warp direction, that's lengthwise,
Okay.
and the weft direction, which is widthwise. They have to test both because fabric almost never shrinks evenly. It might shrink, say, 5% in length, but only 2% across the width.
Right. You need both numbers.
Yeah.
And then do they just wash them straight away?
Nope. Before anything else, they have to condition the samples.
Condition. Like, let them rest.
Exactly. In a special controlled atmosphere. Specific temperature, specific humidity for a set amount of time. Because textiles absorb moisture from the air, right?
Sure.
If the sample's moisture content isn't stable and known, the measurements won't be accurate. Only after conditioning do they mark very precise reference points on the samples. Often they use marks 250 millimeters apart. That's their starting point, the baseline.
Okay, conditioned, marked, then the washing machine.
Then the wash, or the dry cleaning, yeah. Done exactly according to the method specified in the standard, which should reflect the intended care label for the final product.
And drying. Just hang it up.
Definitely not. The drying is standardized too. It might be tumble drying in a specific machine, or flat drying, or line drying, but always following a very precise, repeatable procedure. No guesswork allowed. The speed, the temperature, it all has to be consistent.
And even after it's dry, they don't measure right away. Why wait again?
Good question. Because again, the fabric needs to stabilize. It might regain a little moisture from the air or just sort of settle after the stress of washing and drying. So they recondition the dried samples back into that controlled temperature and humidity environment.
Wow, that's thorough.
It has to be. Only once it's fully stabilized again do they measure the final distance between those original reference marks.
And the difference between the start measurement and the end measurement, that's the shrinkage.
That's the shrinkage percentage, calculated for both warp and weft.
Right.
And that data is gold for the manufacturer. It tells them which threads to use, which stitches are appropriate, and crucially, how much extra fabric maybe needs to be built into the pattern of sizing to compensate for that expected change.
So if this testing is so precise, what about stuff we do at home? Like maybe I use a hotter wash than the label says,
Right.
or throw it in a really hot dryer. Does that mess up their predictions?
Absolutely. Those are what the standards call additional considerations, things outside the controlled test. For instance, we know harsh washing cycles, higher heat, more aggressive tumbling, stronger detergents, they almost always cause more shrinkage.
Because you're accelerating that stress release you mentioned.
Exactly. You're hitting it harder than the standard test, harder than the manufacturer planned for when they stabilized it. You're basically pushing it beyond its engineered limits.
Which brings us right back to that care label again. It's not a suggestion. It's like the operating manual.
It really is. Using a different drying method matters too. Tumble drying, especially with heat, tends to cause more shrinkage than, say, flat drying because of the heat and the friction. All this testing, all these considerations, they give the manufacturer confidence that the garment will hold its shape and integrity if you follow the instructions.
Okay, so let's wrap this up. What's the big picture here? The main takeaway seems to be that good quality clothing isn't just about neat sewing. It's this whole complex dance of chemistry and physics, predicting how materials will behave.
Yeah, it's about managing that stored energy in the fibers, making sure the fabric and the threads can relax together harmoniously without tearing each other apart. You're essentially buying engineered stability.
And all that rigorous testing, measuring shrinkage down to the millimeter, lets them pick the right materials and adjust the patterns so what fits you in the store still fits after you've washed it a few times.
Exactly. They add that extra bit of length or width, knowing it will shrink down to the intended size once the fabric reaches its stable, relaxed state.
So now you know when you see a manufacturer using pre-shrunk fabrics or choosing a specific stretch stitch for like a knit sweater, they're actively designing for longevity. They're fighting those invisible forces.
They are. And that care label. It's the final piece of that engineering puzzle. It's designed to maintain that precise distance between those reference points they marked back in the lab. So maybe think about the clothes you're wearing right now. Consider the hidden tension in those seams. Are they working together, ready for the next wash? Or is there maybe a quiet battle brewing between the thread and the fabric, just waiting for that one wash cycle to finally show itself?